Hello everyone, my name is Vasco Bastos and in this video I will present the ninth chapter of the book Advances in Financial Machine Learning by Marcus Lopez de Prado. I will be talking about hyperparameter tuning using cross-validation. One essential step in fitting machine learning algorithms is hyperparameter tuning. When it's not done properly, the algorithm is likely to overfit and live performance will disappoint. Cross-validation in finance can be a tricky and difficult problem, where many times solutions from other fields are likely to fail. Grid search cross-validation. This can be a first reasonable approach when we don't know many things about the structure of the data. Grid search conducts an exhaustive search for the combination of parameters that maximizes the CV performance according to some user-defined score function. If we take a look at the snippet 9.1, the function clf-hyperfit implements a purge grid search CV. The argument fitperms can be used to pass sample weights, and the perm grid the combination of values that we want to try. Also, this function allows to bootstrap aggregation of the tune estimator, which can reduce the variance of the forecasts. In terms of the scoring function, it can have a huge impact on model performance. For meta-labeling applications, I advise you to use scoring equals to f1, because if some sample has too many negative cases, a classifier that classifies every case to be negative will reach high performance, even though it had not learned from the features how to discriminate between cases. Randomized search cross-validation. For machine learning algorithms with large number of parameters, a grid search CV becomes computationally heavy. So, a great alternative with some good statistical properties is to sample each parameter from a distribution. It has two main advantages. It allows us to control the number of combinations in the search regardless of the dimensionality of the problem. Also, having parameters that are relatively irrelevant will not increase our search time as would be with grid search CV. If you have interest, here you have the last function code implemented with randomized search CV in this slide. Uniform distribution. It's very common for machine learning algorithms to accept non-negative hyperparameters. A uniform distribution will not necessarily be the most effective way to explore the feasibility region of a parameter whose functions do not respond linearly. In those instances, it seems more effective to use a log uniform distribution which draws values from a distribution where the rhythm of those draws will be uniformly distributed. Scoring and hyperparameter tuning. Why use negative log loss versus accuracy? Accuracy can offset a miss with high probability with a hit with low probability, which classifies it as a bad realistic scoring of the classifier performance. Log loss computes the log likelihood of the classifier given the true label, which takes predictions probabilities into account. Log loss can be estimated as follows if you need it. Another reason why log loss is preferred is that it uses the correct label for the size, the probability of the position size, and the sample weight for the observation's return outcome. That is the right machine learning performance metric for hyperparameter tuning of financial applications, not accuracy. Thank you for watching.